Let's look at another example for approximating the binomial distribution using a normal distribution. Suppose that 20% of the trees in a forest are infested with a certain type of parasite. What is the probability that, in a random sample of 300 trees, the number of trees having the parasite will be between 49 and 71 inclusive? That word inclusive means we're going to include 49 and 71 in our probability. Let's write out the information that we know. We have a 20% random sample of 300 trees, and we're looking for the probability between 49 and 71. So 300 trees is n, our sample size, random sample of 300 trees. P is our probability or our proportion. This is written more as a proportion. 20% of the trees in a forest are infested by a certain parasite. That's a proportion, but it's also an empirical probability, 0.2 or 0.20. Then we need Q to calculate our standard deviation if it all checks out. So Q, 1 minus P, 1 minus 0.2 gives me 0.8. So Q is 0.8. Now we need to check n times P and n times Q. 300 times 0.2 and 300 times 0.8. 300 times 0.2 is 60, which is definitely greater than or equal to 5. 300 times 0.8 is 240, and that is greater than or equal to 5. So we can use the normal. Now we need our mean and our standard deviation. Mean is n times p, we just found it, 60. Standard deviation, square root n times p times q. Square root 300 times 0.2 times 0.8. We'll bring up the calculator. 300 times 0.2 is 60 times 0.8 will give us 48. Take the square root, 6.9. And these are trees. So 60 trees on average and 6.9 trees for the standard deviation. And now we can write our probability statement. So x is between 49 and 71 inclusive, means we're going to have that equal sign there. I like to draw my graph before I make the new statement. So I'm going to come over here and draw my graph. The mean in the middle, 60. And then I have 71 here and 49 on the left. But I need to go slightly below 49 and slightly above 71 so that we catch them. Remember, the rectangles that we're talking about for the binomial don't sit only on top of those numbers. They sit around those numbers. So we need to make sure that we grab the right continuity correction for them. So that means we're going to use 48.5 just below 49 and 71.5 just above, and we'll find this area in the middle. Now, if you recall, area in the middle, I'm going to draw some little pictures here, hoping that this will help out a little bit in the visualization of what we're doing with Excel. Let's write our probability statement first. So this binomial probability becomes a normal probability by taking 48.5 and 71.5. So we're going to take 71.5 and below minus 48.5 and below so that we get between 71.5 and 48.5. So the idea here is this extra piece, we want to cut that off. And we'll label some stuff. So binomial would be the first probability, and if we use the normal to approximate, it's the second. Okay? And then writing it out using Excel or Google, norm.dist, 71.5, mean, standard deviation, true, minus norm.dist, 48.5, mean, standard deviation, and true, and just making the connection, the 71.5 and the 48.5 corresponding to those normal distributions. And let's move over into Excel. So there's our first one, 71.5 and below, and we're going to subtract off 48.5 and below. And we get 90.4. There's a 90.4% probability that in a random sample of 300 trees, the number of trees that have the parasite will be between 49 and 71. So a 90.4 probability that we'll get between 49 and 71 trees that have the parasite. And if we think about it, this should make sense too. In our graph, our mean is 60. One standard deviation away from 60 would be 66.9. And below would be 53.1. So one standard deviation away is 68%. Two standard deviations away will get us up to 73.8 on this side. That's 95%. So two standard deviations away from our mean, we're between 46.2 and 73.8. Those numbers are really close to the values we're looking for, and those numbers represent 95% of our values. So we should be close to that 95%, and we are.